All right, welcome to day 19 of extension to a question a day. Write down the sums to infinity of those geometric series. Well, for the first one, let's have a look. Get a pen. I think a is equal to 1 and r is equal to x. So sum to infinity is a on 1 minus r, which is 1 on 1 minus x. And this one, a is 1 and r is minus x. So the sum to infinity is a on 1 minus r, which is 1 minus x. So it's 1 plus x. All right. So basically they want us to show this. Now it's involving logs. So it sounds like it's a bit of integration. Log of 1 plus x on 1 minus x is actually log of 1 plus x minus log of 1 minus x, which is looking like you've integrated. The derivative of this is the derivative of the function over the function itself, and the derivative of this is the derivative of the function over the function itself. So this, if you find d dx of this thing, right, because you're suspicious that integration has happened with those logs in it, right, you'll get that, which is 1 on 1 plus x plus 1 on 1 minus x. So that's what this left-hand side of it is to do with something, right? It's to do with integrating that. So the right-hand side must be the equivalent of that. The original series they gave us, like, see how 1 on 1 minus x is equal to that, and 1 on 1 plus is equal to that. Well, let's add them together and see how we go. So 1 on 1 minus x is equal to 1 plus x plus x squared plus x cubed plus, and 1 on 1 minus x was equal to 1 plus minus x plus x squared. So minus x plus x squared minus x cubed plus, right? And I just got to fix that because I put the wrong sign there. That's supposed to be a minus. All right, which is 2. And the x's are gone, and plus 2x squared, and the x cubes are gone, and plus 2x4, and plus 2x6, and plus. All right, so now I just need to create a bit extra room. So let's just insert a page break in here, and we'll go back up. And we're saying that that's equal to 2, 1 plus x squared plus x4 plus x6 plus x8 plus da 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 da. Now if I integrate the 1 on 1 minus x and the 1 on 1 plus x, if I integrate that left hand side, then that'll be the same as integrating the right hand side because they're equivalent. So this one here was minus of ln of 1 minus x plus ln of 1 plus x. And this side, well, we've got to do twice the integral of 1 plus x squared plus x4 plus x6, etc. So this is ln of 1 plus x on 1 minus x. And this is twice, and it's like a half of, no it's not, hold on, I was looking at the wrong term. The integral of 1 is just x, and then the integral of x squared is a third of x cubed, and the integral of x4 is a fifth of x5, and the integral of x6 is a seventh of x7 plus ... right? Now just go back up and we'll see what we're looking at. We want twice that. Okay, well that's pretty well it. Natural log of 1 plus x on 1 minus x, right, does equal twice of x plus x cubed on 3 plus x5 on 5 plus x7 on 7 plus ... So that does equal that. Now, the size of x that we're talking about here, just out of interest, the size of x is less than 1, so x is some decimal, positive or negative, somewhere between -1 and 1. And the reason that that's important is really when I did my logarithm stuff here, when I came out here, it should have been minus natural log of 1 minus x plus natural log of 1 plus x in absolute values. But x is a decimal, so 1 minus that is still going to be positive, and 1 plus that is still going to be positive, since the absolute value of x is less than 1. So that's why I could legit put those not the absolute value signs in there. I really probably should have explained that. All right, so I've shown that that's the case. Show how the series can be used to evaluate natural log of 2. All right, so first of all, I'd like to know what I've got to put in for x so that 1 plus x on 1 minus x is going to equal 2. So we'll get natural log of 2. So I'm going to have to solve that one out. Let's see, 1 plus x equals 2, 1 minus x. 1 plus x equals 2 minus 2x. So we got 3x equals 1. So x is a third I'm going to have to put in there. All right, so let x equal a third, and we're saying that the natural log of 1 plus x on 1 minus x is equal to 2x plus x cubed on 3 plus x5 on 5 plus x7 on 7 plus, well, then the natural log of 1 plus a third on 1 minus a third equals 2 a third plus a third cubed on 3 plus a third to the fifth on 5 plus ... So this is natural log of 2 equals 2 times a third plus 1 on 81 plus 1 on now 3 to the power of 5. 3 to the power of 5. 1 times 5 is 12, 1, 5, etc., etc. And now the question said, show how we can use it to evaluate it correct to 3 decimal places. So I just want to know how many terms in those brackets are going to be of any use to us, right? So this is 0.333333, etc. Right? Now 1 on 81 is 0.01234567. That's pretty interesting, isn't it? And 1 on 1215 is plus 0.1238230. Okay, so we're trying to evaluate it correct to 3 decimal places. So we only need those 3 terms to 3 decimal places. So we've got 2, and we've got like to 5 decimal places, we've got 1, 2, 3, 4, 5, plus we've got 0.012334, plus we've got 0.0000 0.0082. So if we did that to 5 decimal places, we get 0.33333 plus 0.1234 plus 0.00082. We get 2 by 0.34649. Now we only need it to 3 decimal places, so it's 2 by 0.346, and we end up with 0.692 to 3 decimal places. But what's after there? There's a 9 after there, right? When you're doing it, so that would be 0.69298, which is 0.693. Cheerio.